and also a good emitter of heat. What we have just talked about, it explains why a dark color vehicles are not popular in the tropics. I mean, in the southwest, they are not popular in the northern part of Nigeria because of the high intensity of radiation over there. Because they have a very high intensity of radiation, I mean, like the sunlight, okay? Because their intensity of radiation is too high compared to the southwest, okay? That is why you will never see any of their vehicle that have maybe that being colored as black, because those surfaces, either dull surface or a rough surface, will be a good absorber or a good emitter of heat. And that's the reason why dark color vehicles are not popular in the tropics. That's that. I want us to quickly consider the following question. Question number 1 says, in which of the following are the substances arranged in descending order of their thermal conductivity? Thermal conductivity. Thermal is heat. Another word for thermal is heat. Okay? We are given some substances. We have copper, we have steel, we have glass. 3 substances. Okay? These are the 3 substances. We are now told that out of these 3 substances, if they are to arrange in a descending order, let's take a look at the word descending order. Descending. Okay? If you say ascending, you are taking from the lowest to highest. Ascend. Descending from the highest to lowest. Okay? So, which of these substances, okay, with their thermal conductivities, the question says, in which of the following are the substances arranged in descending order of their thermal conductivities? Okay? From the word conductivities, that is, which of, if you have to arrange them in a particular order, which of them will conduct heat most? And which of them will conduct heat less? That's what the question is saying. Okay? Summarily, let's say we suspend these 3 material into a hot substances. Let's say we have, okay, let's take for example a metallic material. We put a hot water, very hot water, and we now suspend this material into that hot liquid. Before you know it, the rate at which copper will conduct heat will be different from the rate at which the steel will conduct heat. And the way the steel will conduct heat will be different from to that which glass will conduct heat. So if you have to take it in a descending order, copper will conduct heat most, followed by steel, followed by glass. That is, if you have to have it, you go to the copper, followed by steel, followed by glass, in a descending order. In fact, glass is a poor conductor of heat, because this is not a metal. Okay? But copper is a metal, steel is a metal, but they have what they call they have what we call coefficient of expansion of these 2 materials is different. That is why their thermal conductivity will also be what? The difference. And that's the best answer we are having here, we have answer the first answer says copper, steel, glass. Number 2, for B, steel, copper, brass. For C, steel, brass, copper. For D, copper, glass, steel. Copper, steel, and then glass. And that's the answer for question number 1. Question number 2. Which of the following makes metal ideal cooking material? High coefficient of expansion. B. Good conduction of heat. C. Low specific heat capacity. D. Poor radiation of heat. The answer there is B. Good conduction of heat. Because all these materials are metal and they have the ability to conduct what? Heat. That is the reason why when you put water inside the pot and you put it on a source of heat, before you know it, the water starts boiling. Because the pot is a metallic material that has the ability to conduct heat. So the answer there is good conduction of heat. Question number 3. A room is heated by means of a charcoal fire, and the occupant of the room standing away from the room is warmed mainly by A. Radiation, B. Conduction, C. Convection. The answer there is radiation, because we said radiation traveled in a vacuum. So the occupant of the room experiences the heat by a process that takes place, okay, and that is what? Radiation, not conduction. Conduction, heat passes through a solid, either a metal, or it can also pass through a liquid or gas. For convection, it is only liquid and gas only. But for radiation, it takes place in a vacuum or in air. And that's the best answer. The answer there is radiation. Question number 4 says, the heat from the sun reaches the heart by the process of DAS. A. Radiation, B. Convection, C. Conduction, D. Evaporation. The answer there is radiation. So the heat from the sun reaches the heart by the process of radiation, not convection, not conduction, not evaporation. Question number 5. Which of the following phenomena explain the fact that a house whose roof is coated with white paint will be cooler in the hot season than one coated with black paint? The phenomena in charge of this is conduction, in the sense that we have a dull surface and we also have a bright surface. This will be a good absorber. This will be a poor absorber. And a good absorber will also be a good emitter. A poor absorber will also be a poor emitter of heat. So it's as a result of conduction. One will conduct heat than the other. One will conduct heat, the other will not conduct heat. Okay? So we are told that a house coated with a white paint will be a poor absorber than the one coated with a black paint, and that will be a good absorber. Both of them are conducting heat, but yet at which they are conducting that with heat difference. One is a good absorber and the other one is a poor absorber. And that's the phenomena behind it. Question number 6. The mode of heat transfer which does not require a material medium is DAS, conduction, B, radiation, C, convection, D, propagation. The best answer there is radiation, which does not require a material medium. For conduction, it can pass through both solid, liquid, and gas. For convection, it is only liquid and gas. For radiation, it passes through a vacuum. As I have told you, okay, And the best answer there is radiation. For question number 7, a hot metal is suspended in the open air. As it cools, it loses heat by dash. This is what we are talking about. We have a hot metal. Let's assume you put this hot metal in a source of heat. By the time the metal gets heated, you bring it out and you suspend it to the atmospheric air. Okay? You just put it down for air to blow and the breeze to blow around it. So by the time this hot metal begins to lose heat, the question says, as it cools down, it loses heat by A, conduction only, B, convection only, C, radiation only, and then D, conduction and convection, E, convection and evaporation. The best answer there is radiation. Radiation only. And that is option C, radiation only. Let's consider the last question. Heat may be transferred by conduction, convection, and radiation. The question is, by which of this method does heat travel to vacuum? It's the same thing with the last question we have, but they try to restructure the question in another way. By which of this method does heat travel to vacuum? A, conduction only, B, convection only, C, radiation only, D, all the three methods, E, none of this method. And the best answer there is radiation only. Heat traveled in a vacuum by a process of radiation only.